Mrs. S with Owltree Montessori. Today I want to show you the Montessori Golden Bead material. This material is the most concrete material to teach linear counting and base 10 operations, the decimal system. It's perfect for preschoolers through first graders who are learning linear counting, counting 1 through 10, focusing on the teen numbers, counting by tens, and counting 1 to 100, and who are learning operations, the decimal system, and learning to add, subtract, multiply, and divide within the decimal system. Second through fifth graders use this material when they need support, learning linear counting skills and operations. In fourth through sixth grade, children are introduced to square rooting, binomial and trinomial expressions, and also exploring the divisibility of numbers. The Montessori math materials progress sequentially from concrete to abstract. Concrete refers to hands-on physical objects that illustrate concepts. Abstract refers to symbols, equations, and general principles without any direct physical reference. This material comes with the actual beads that represent each quantity. We have 1 bead representing 1. We have 10 loose beads grouped together to make 10. The 100 square is 10 groups of 10 together. And the 1000 cube is 10 100s grouped together to make 1000. After a child has been introduced with the beads, the actual beads, there is a wooden material for the squares and cubes. So as they're building and reading numbers and doing operations, it's a little easier for them to work with. Numeral cards come with this material as well. These are the small numeral cards and these are the large numeral cards. And children put them together to build and read numbers as well as match them with the quantity. You can see that each card can be layered into its place value from the expanded form into the standard form, and then children read numbers. In the linear counting strand, the first lesson we can give with the golden beads are the teens. We'll use the 10 bars and the unit beads and the numeral card 10, and we'll have our units here. So we would get out the quantity and we'll have our numeral, and we'll just add 1 bead at a time. This is 11. This says 11. Let's add another bead. This is 12. And we have 12. And we continue until we reach 19. The next lesson in the linear counting strand is the tens. So once a child has reached 19, we know that when we have 9 and add a 10th, that's an exchange to the next place value category. We would exchange all of these 10 loose beads for 1 group of 10, and now we have 20. And then we can continue adding 1 each time. 21. 22, until we reach 29, where then we'll have a 10th bead that will make us exchange for 30. 30, and continue linear counting. Another way that you could do this, if you didn't want to do counting by 1, you want to really focus on counting by tens, you could just have your tens out. We have another 10. Oh, that's 40. And they can count 10, 20, 30, 40. Yep, that's 40. And do the tens that way. 2 different ways you can do the tens lesson. To introduce the decimal system, we show the child the quantity. This is 1, this is 10, this is 100, this is 1000. Then in isolation, we show them the numeral card. This says 1, this says 10, this says 100, this says 1000. And finally, we help them match the quantity with the symbol. The Crisis of 9 lesson teaches the rule that each place value category cannot have more than 9. Once we have 10 in a place value category, we must exchange for one group in the next higher place value category. I have 9 unit beads here. When I add a 10th bead, I know this is the same as one group of 10. I must exchange these 10 loose units for one group of 10. 10 can't stay loose, we like to say. When I have 9 groups of 10 and I add a 10th group, I know 10 tens is the same as 100. We'll exchange 10 tens for 100. When I have 9 groups of 100 and I add a 10th group, that is 1000. I will exchange 10 100s for one group of 1000. The exchange game is a follow-up from the Crisis of 9 lesson. It gives children more practice with encountering more than 9 in each place value category and needing to regroup via an exchange into the next higher place value category. We will give the child a large quantity of beads. We know that they're going to have more than 9 in each category and need to exchange. The only category we won't have more than 9 in is the thousands place, because the golden beads are limited to the thousands place value category. Let's see what we have. We're going to count and exchange, regrouping until we have our final number. 2, 4, 6, 8, 9, oh, there's 9, 10. Oh, that's a group of 10. We're going to exchange and we have 4 units. 2, 4, 6, 8, 9, 10, that's 100. Let's exchange for 100. Now we have 10, 2, 4, 6, 8, 9. There's 10. That's 1000. We have 1, 2, 3, 4, 500s. That's okay. And then we have 3000s. Our final number is 3,510, 11, 12, 13, 14. 3,514. This lesson is called the 45 layout, or the bird's eye view. It teaches children to associate the quantity with the numeral. It's called the 45 layout because you need 45 of each quantity. You need 45 unit beads, you need 45 10 bars, you need 45 100 squares, and you need 45 1000 cubes. The final result is too large for me to show here, but I do have a picture that you can look at to see what the result will be, and it is very impressive. Children start with 1 at the top, right of the rug, and go all the way down to 9. Then continuing on to the left, they start with 10 and go down to 90, followed by the hundreds, 100 to 900, and then 1000 to 9000. They really have the impression of the decimal system, and they can associate the quantity with the symbol. Building and reading numbers with the golden beads allows children to practice the place value category, reading numbers, making numbers. It's a great practice for that early learner, preschool through first grade. So I might give the child these numeral cards, 3,462. The child will know that they need to go get 2 units, 6 of the tens, 4 of the hundreds, 3 of the thousands. We like to do something called the magic slide with our numeral cards, where we stack them up and then we slide them across to make that standard number. They'll get all the quantity for it. So they'll get out 3,460, 246, yep, and 2 units. Once a child has had lots of practice building and reading numbers with the golden beads, we can introduce them to the operation of addition. It would begin just like the fetching games, where we would give them a quantity using the numeral cards and they would go and get it. We call this the first addend. Then they would build and bring back a second addend. And we will show them how to combine for addition, beginning in the units place and moving on to the thousands place. We want to make our first equations static, ones without exchanges. So there will be no regrouping here. This is so that they can focus on the process of addition. Start with our units and push them together. Then our tens place, then our hundreds, and finally the thousands. So 2,142 plus 1,426 is 3,568. When we introduce exchanges, we call this dynamic, and we will make an exchange from one category to another and regroup an amount. Let's say that in the tens place of our second addend, instead of a 2, we have 7 tens. This will mean that we will have more than 9 in the tens category and we'll need to make an exchange into the hundreds. Now, instead of 2 tens, we have 7 tens in the tens place. So after we combine our units, we're going to combine our tens, and we're going to realize, oh, we need to make an exchange. 2, 4, 6, 8, 9, 10. Oh, remember, 10 tens is the same as 100. 10 can't stay loose. Let's regroup. For static subtraction with the golden beads, no exchanges, no regrouping, we start with the minuend at the top and we will pull the subtrahend down. We'll take the subtrahend away from the amount that we have. I've made the subtrahend in the numeral cards, so we know how much we need to take away. We need to take 4 away from this 6. So I'm pulling that 4 down, I'm taking it away, and I'm building the subtrahend at the bottom. 110 taken away, take away 100, take away 1,000. And now the answer, called the difference, is what is left over. For a dynamic subtraction equation, we will make an exchange from the units place into the tens place. You can see we have 2 in our minuend, and our subtrahend tells us to take away 5. And we don't have enough, but we can go to the next place. We have a group of 10 that we can ungroup and exchange for 10 loose units. So we will do that now. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now we have enough and we can take away 5. 1, 2, 3, 4, 5. And there's our subtrahend of 5. And we have 2, 4, 6, 7 left over. Multiplication with the golden beads is very similar to addition. We combine to get a final product. We have the child build 1,232 3 times, and we're going to combine them to get a product. We have 3,696. What if we had an exchange, though? This was a static multiplication equation. What if we had a dynamic where we had more than 9 in a category and we needed to regroup? Let's say that instead of 3 tens, we have 4 tens. We have 1,242 times 3. This means that we will have an exchange in the tens place. This is a dynamic multiplication equation. We combine as usual, beginning in the units. And now when we get to our tens, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh, 10 can't stay loose. We must exchange for 100. For division with the golden beads, I'm using 3 Skittles from the stamp game. We're going to use the number 633. We won't have any thousands this time. The difference with division is that we start with the largest place value category when we share among our divisor. So I'm going to start sharing, and it has to be equal. It has to be a fair share. So each get 1. We still have more hundreds to share. So we're going to share them out, and it's even, it's fair. Each child gets 2. Then we'll move on to our next largest place value category, the tens, and we will share. Okay, that's fair. And finally on to the units, and each gets 1. So the quotient, the answer in a division equation, is what each child gets, the share of 1. Each child got 210, 11. 211, that's our quotient. For a dynamic, let's say I had 7 hundreds to share. Well, I can't share a third hundred because each child won't get one. So I'm going to ungroup this 100 for 10 tens. So I'll exchange that for 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then I would continue sharing tens evenly and exchanging if necessary. Let's say in the units place I had 4 units instead of 3 units. So I can't continue sharing a second unit bead. So this would be my remainder. I would have a remainder of 1. We are going to use the golden beads to explore the divisibility of numbers. It is helpful for children in 4th through 6th grade to determine what numbers a certain number is divisible by. This helps with fractions, specifically finding the lowest common denominator so that a child can reduce a fraction to simplest terms. What we want to do today is see if we can discover a rule for when a number is divisible by 2. We're going to use the number 1,126. I'm going to set this over here. I'm using the 2 green Skittles from the stamp game. You could also use 2 trays with the golden beads to divide this number. I have my number on this divisibility table, 1,126. We'll start with our largest category. It's not fair. I can't share 1,000 with both Skittles. I'm going to exchange this for 10 hundredths. I've exchanged this 1,000 for 10 hundredths. And now I'm going to share the hundredths. Each got 5, and I have 1 that I can't share, so I'm going to exchange this for 10 tens. I have 100 being exchanged for 10 groups of 10. And let's share our 10s. Each got 2, 4, 6. Each got 6. That's even and fair. So let's go on and share our units. 1. All right, each got 3. The number 1126 is divisible by 2. It divides evenly into 2. So we're going to write yes. But what if we had 1127? Let's get out one more bead. That is not divisible. It will not share evenly. So 1127, no. What about 1128? That is divisible. 1128 is divisible by 2. So we'll write yes. What about 1129? Let's get out one more bead. Okay, not even. No. 1129 not divisible. 1130. Let's get out one more bead here. Yes, it is. So we have a pattern appearing here. We have yes, no, yes, no, yes. Let's look at these numbers. Let's look in the units place. We have 6, yes, 7, no, 8, yes, 9, no, 0, yes. What we're seeing is even numbers are divisible by 2, while odd numbers are not. I'm going to circle these here in the units. All right, let's try another number. Let's try the number 70. Is 70 divisible by 2? One for you. I need to make an exchange. I'm exchanging 10 loose units for this one group of 10. I'm going to continue sharing. Yes, 70 is divisible by 2. Let's write yes on our chart. And we'll circle the 0. 0 is an even number. That's holding with our rule. Well, what about 71? 71 is not. No. What about 72? Yes. What about 73? No. What about 74? Yes. We are seeing that our pattern is holding, that even numbers are divisible by 2 and odd numbers are not. So now we can create a rule. Anytime we have a number ending in an even digit, it will be divisible by 2. To find the square of a binomial, we are going to use the 100 square from the Golden Bead material. We're going to use the 7 square and the 3 square from the bead cabinet material. And we're going to use the 7 bead bars from the Binomial bead bar material. This 100 square we can look at as 10 times 10. We can write it like this, or we can write it like this. This exponent 2 tells us how many times to multiply the base number by itself. To make a binomial, we are going to separate the 100 square into 2 parts. I'm going to do 7 and 3. We've separated the 100 square into 2 parts, 7 and 3. We're going to do the same down this side. You can see we have made 4 figures. Up here in this corner we have a square that is 7 times 7. We can use our square, 7 square, to overlay and see, yes, this is 7 times 7, which is 49. we can write this as 7 times 7. 7 squared equals 49. Over here, we have 7 times 3. We'll use our bead bars to show 7 times 3. And that's 21. Down here, we have 3 times 7. And we'll use our bead bars to show it's 3 times 7. And then in this corner, we have our 3 times 3, which is 9. That's 3 squared is 9. Now let's add up all that we have and see if we can get to 100. 49 and 21 is 70. Plus our 21 plus 9, that's 30. And 70 plus 30 is 100. We're going to find the square root of 169. We're using the golden beads, and we're going to start with our largest category, the 100s place, and make the biggest square that we can. All right, 100 is a square. Let's share evenly along the sides with our tens. And there's all the tens. And now let's move on to our units. We're sharing 9 units. Let's make a square. Okay, we've built a square using the golden beads. To find the root, we're going to look right along the bottom. We have 10 and 3 units, 13. The square root of 169 is 13.